The Microsoft Baseline Security Analyzer, or MBSA, scans a workstation or server for any security holes or weaknesses. It can also determine if all of recommended security updates and patches have been applied. If any holes are found, the tool provides steps to help you fix them. Your first step is to select a PC to scan, which can be either your local PC or any networked machine. You can even scan several PCs in one shot by specifying a domain name or a range of IP addresses. If you choose to scan one computer, by default the scan points to your local machine, but you can target a different PC by entering its IP address if it is in the same network or subnet. From the MBSA scan menu, you can choose to check some or all of the following, which are all of the selected by default. First, the window administrative vulnerabilities. MBSA checks for Windows account-related issues, such as an OpenGuest account or too many administrative accounts. It also looks at the numbers of file shares at the PC file system to make sure you're using NTFS instead of FAT for better security. Second, weak passwords. MBSA looks for a blank or weak passwords through all of the accounts. Third, IIS administrative vulnerabilities. For machine running IIS 5 or 6, MBSA scans to make sure all of the necessary default security options and hotfixes have been run. The tool unfortunately does not support IIS 7. Also, we have the SQL Server administrative vulnerabilities. MBSA scans for any versions of SQL Server of Microsoft Data Engine on the machine, looking at the authentication mode to see if you're using window authentication or mixed mode. It also checks the status of the system administrator account password. And finally, it looks for secure updates. MBSA checks the status of all of the security updates to determine if any are missing. You can also use this option to install Microsoft Update on a client, which MBSA uses to scan for scented applications. Finally, you can tell MBSA whether to use Microsoft Update or Windows Server Update services in its scan. After you select the appropriate options and computers, you trigger the scan, which typically takes several minutes to run. Then MBSA generates a full on-screen report displaying the results of the scan item by item. The report groups its findings into categories matching the options in the scan menus, such as the administrative vulnerabilities, SQL Server status, and security updates. Before we can discuss how IPsec works and review the steps for IPsec configuration, we must understand some of the features, terminology, and components of IPsec framework. IPsec is an architectural framework that provides cryptographic security and services for IP packets. IPsec is an end-to-end security technology. This means that the only nodes aware of the presence of IPsec are two hosts using IPsec that communicate with each other. Intermediate routers have neither knowledge of the security relationship nor any need to know, and they forward the IP packets as they would to any others. Each computer handles security as its respective end, with the assumption that the medium over which the communication takes place is not secure. IPsec can be deployed to protect data transmission in the following scenarios: local area networks, wide area networks, and remote access. Typically, both sides requires a shared IPsec configuration, which is called an IPsec policy. This is to establish security settings that will allow two systems to agree on how to transmit secure traffic between them. The Microsoft Windows 2000, Windows XP, Windows Vista, Windows 2003 and Windows Server 2008 implementation of IPsec are based on industry standard developed by the IETF IPsec Working Group. IPsec has two principal goals: to protect the contents of an IP packet and to provide a defense against network attacks through packet filtering and the enforcement of trusted communication. Both goals are met through the use of cryptography-based protection services, security protocols, and dynamic key management. This foundation provides both the strength and flexibility to protect communications between private network computers, domain, sites, extranets, and dial-up clients. It can be even used to block receipt or transmission of specific traffic types. IPsec has a number of features that can significantly reduce or prevent the following attacks. First, packet sniffing. A packet sniffing attack is one in which an application or device called a packet sniffer monitors and reads network packets as they traverse a wire or wireless network. If the packets is being sniffed are not encrypted, that is, if they are being transmitted as a clear text, a packet sniffer can provide a full view of the data context or payload that it contains inside the packet, thus compromising the confidentiality of the data. IPsec includes mechanisms that provides data confidentiality by encrypting the payload of the IP packet. Also, we have the data modification. An attacker can modify a network packet that is on transit over the network and send counterfeit data which might prevent the receiver from receiving the correct information or might allow the attacker to obtain additional, possibly secure information. IPsec uses cryptography-based keys that are shared only by the sending and receiving computers to create a cryptographic checksum for each IP packet that is secured using IPsec. This is to protect the integrity of the data. Any modification to the packet data alters this checksum, which indicates to the receiving computer that the packet was modified in transit. We also have the identity spoofing. An attacker can falsify or spoof the identity of either the sending or receiving computer by using special programs to construct IP packets that appears to originate from valid addresses inside of an untrusted network. IPsec allows the exchange and verification of identities without exposing that information to interpretation by an attacker. This process, called mutual authentication, is used to establish trust between the communication system, after which only trusted systems can communicate with each other. Then you can start with the communication. After identity are established, IPsec uses cryptography-based keys shared only by the sending and receiving computers to create a cryptographic checksum for each IP packet. The cryptographic checksum ensures that only the computers that have the acknowledgement of the keys can set each packet. We also have the man-in-the-middle attacks. Love these ones. In this type of attack, someone between the two communication computers is actively monitoring, capturing, and controlling the data transparently. IPsec protects against man-in-the-middle attacks through a combination of mutual authentication and the use of shared cryptography-based keys to confirm the integrity of each packet as well as the identity of the sending and receiving computers. And finally, we have the denial of service attack. This type of attack prevents the normal use of computers or network resources. Flooding email accounts with unsolicited message is an example of a DOS attack. IPsec uses IP packet filtering methodology as the basis for determining whether communication is allowed, secure, or blocked. This determination is based on the IP address range, IP protocol, or even specific TCP, IP, and UDP ports. You can configure IPsec to use one of two modes, transport mode or tunnel mode. Use transport mode when you require packet filtering and when you require end-to-end security. Both hosts must support IPsec using the same authentication protocols and must have compatible IPsec filters. On the other hand, use tunnel mode for site-to-site communication that cross the internet or other public networks. Tunnel modes provide gateway-to-gateway protection.